Hello YouTube. In this video we're going to start our exploration of the rectangular coordinate plane as we start to explore some basic concepts of algebra getting into our honors pre-calculus course. So let's go and start with a few kind of straightforward pieces of information here. Starting with the fact that we refer to this xy coordinate plane here as the Cartesian coordinate plane. We could also just call this the real number plane, but we'd say that this real number plane has four quadrants in terms of important vocabulary. We use this quite a bit, four quadrants. But also an x-axis and a y-axis. So some things we'll point out here is that our x-axis, you'll notice in this image here or this one here, that our x-axis is our horizontal axis always, and our y-axis is our vertical axis here. And so we can see that our horizontal and vertical axis meet here, and they meet specifically at a right angle at a point that we refer to as the origin. So the origin is kind of like this space where this entire number plane originates from, kind of where it gets its name here. And we can see that these two I guess horizontal and vertical number lines meet at the origin and the right angle and cast out these four quadrants. So really quickly here, our four quadrants are 1, 2, 3, and 4, and we always refer to our quadrant 1 as being our positive quadrant. That is to say we have positive x's and positive y's, but it goes around counterclockwise, and you'll notice also that we're using Roman numerals here. So we can write Q1, Q2, Q3, Q4 with Arabic numerals, but we're just using Roman numerals here. So looking at these number lines here, we see that we can I guess graph points or plot points, what we're really interested in doing a lot of the time. So we say that each point in the plane corresponds to what we call an ordered pair. And the reason why this is an ordered pair is because this pair of values here, the x coordinate and the y coordinate, are always in this order x and then y typically. So we say that the x coordinate does represent a directed distance from the y-axis to the point, and the y coordinate represents the directed distance from the x-axis to the point. So one thing I want to point out here is this: the x coordinate, notice here it says represents the directed distance, okay, which means that the direction you go matters, and also that it's from the y-axis to the point. So to look at this point xy that they've graphed up here, you can see that we've gone x units away from the y-axis and they've gone y units away from the x-axis. But basically, the way I'd like to have you look at it is starting at the origin, we're going to deviate x units in a positive direction and y units in a positive direction in this case. And we arrive at this point, and that's the same as going y units up and x units out. You can see that this always forms this rectangle that'll land you at this point right here. So we say that these right here are the coordinates of a point, but also some ordered pairs. So what I want to do is just kind of play around with this idea. And what I want to do is give the coordinates for 4 points in the coordinate plane that satisfy the following conditions that I've listed here. So once we give these coordinates, what we'll do is we'll then plot them and we'll label the points A through E. So there should be 5 points here, and let's see if I can get this to write on here. 5 points. So with these 5 points, let's start with number 1 here. Point A should be in quadrant 1. So because quadrant 1 I know has all positive values, I'm going to say, how about the point 2, 3? And what I want to do is go ahead and starting at the origin, we'll go right 2 up 3, grab this point, we'll label it with A. So pretty neat, right? Looking at the rest of these, we say point B should be on the negative x-axis. Well, where would this be? Well, knowing that our x-axis is our horizontal axis and that we have a directed distance that is important here, negatively, we would move left from the origin. So I'd go maybe left, maybe 4 units, and I'd land right here, and I could call this B. But this point B, we want to also give the coordinates here. My specific point on the negative x-axis is negative 4, 0. Point C at the origin, this one here, let's see if you got it right. C is this, and my favorite part about the origin point is that its directed distances are 0 and 0 from the origin. You're right there. So for points 4 and 5, let's read these critically here. Say point D should have the same coordinates as point A. So point A here with this 2, 3, but have an opposite x value. And so what we mean by opposite x value is that, well, then I suppose this point D would have a negative 2 instead of a positive 2, but the same y coordinate here. So as we graph this here, we go left 2 and up 3. Okay, we're going to label this with a D here. We're going to say, you know, I guess we'll look at how it compares to point A here in a minute. And then finally, let's look at point E. We say point E should have coordinates that are opposites of point A. So basically, if point A is 2, 3, then we have negative 2, negative 3 here on my particular point. Whatever point you use is fine. But if I go left 2 and down 3, I certainly land here. I'm going to land this here as E. And so, you know, one thing I didn't ask us to do that we could do is determine in which quadrant these lie. But one thing I guess I do ask you to do, looking down here, is ask about point B, in which quadrant it lies. So we say, in which quadrant does point B lie? Well, you know, clearly A is in 1, D is in 2, E is in 3, there are none in 4, but B it's kind of in between quadrants 2 and 3. And so since it lies between 2 and 3, we'll make a note here. It lies on the negative x-axis. Negative x-axis. It actually does not lie within a quadrant at all. Okay. So looking at this, we say, what are the coordinates for point C here? Well, looking at point C, we did mention that the origin is definitely at the point 0, 0, and that's a good one to note. I do ask these questions about which axis do points A and D have symmetry. Now, a word here we're going to use, symmetry, basically means that it's kind of like a mirror image. So we say A and D, about which axis do we have symmetry here? Well, we notice that over the vertical axis, these are the same distance from the vertical axis here. This is the same distance. And so since that's the case and they're a mirror image of each other also, I could fold one over the y-axis onto the other, then we have y-axis symmetry. And an interesting thing happens when you negate the x value or make the x value opposite, we see it popping over the y-axis. So in which quadrant does point D lie? Well, point D definitely lies in quadrant 2, so we're going to write Q2. Which quadrant does E lie? That lies in quadrant 3. And then for the last part here, we say, do points A and E exhibit symmetry about the x-axis or the y-axis? Now, if A and E, these are these 2 points here, here, and here. If they had, x-axis symmetry over the x-axis, then it would have, popped the A value down here 3 units below the x-axis here. Or if it would have had x-axis symmetry, E would have popped up here where D is sitting right here. And in terms of y-axis symmetry, if we were to have y-axis symmetry, E would pop over to here, which doesn't fall onto A, and A would pop over here to D. So one thing I want to note here is that quadrant 3 is that it has no x-axis or y-axis symmetry. Cool.